Hi there, welcome to Eduretics, where we make your high school life simple. I'm Aniket, and in this video we're going to discuss some hard difficulty questions on nonlinear functions as part of our digital SED math practice, where we're currently doing advanced math. So make sure you pause and try to solve the questions yourself before looking at our solutions. Okay, let's begin. So the first question, fx is equal to 4x squared plus 64x plus 262. The function g is defined by gx is equal to f of x plus 5. For what value of x does g of x reach its minimum? This looks like a question where you'll need to figure out the g of x, the complete expression, and then find out the minimum value, but that's not required. It's a transformation question. So the transformation used here is x going to x plus 5. Okay, this is the transformation used here. This means the graph will be translated 5 units to the left. It will be translated 5 units to the left. So if we just draw an indicative graph of the function given, the fx given, so it's like this is the curve given for fx. 5 units to the left, it looks like this. So initially the vertex was, so minimum in a quadratic function is basically the vertex, provided the quadratic function opens upwards, the parabola opens upwards, so which is there in this case. So the vertex is the minimum point. This is the vertex. Now the vertex is defined by minus b by 2a, the x coordinate of the vertex, minus b by 2a. So in our case, for fx, this is going to be negative 64 over 8, which is negative 8. And then it is shifted 5 units to the right. So 5 more subtracted, negative 8 minus 5, which is minus 13. The vertex now exists here for the transformed function, which is g of x. So option A is correct. Okay. Next question. Also, I can make a video on transformation functions. You can check out in the quick math playlist. Okay, next question. A quadratic function models a projectile's height in meters above the ground in terms of the time in seconds after it was launched. The model estimates that the projectile was launched from an initial height of 7 meters above the ground and reached a maximum height of 51.1 meters above the ground 3 seconds after the launch. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? Okay, the question looks pretty long. It's a paragraph. They've basically described the situation, the whole situation. You just need to, visualize it graphically. So let's do this. Let's say this is our XY plane. Okay. And it's saying that it was launched from the ground, like 7 meters above the ground. Let's say this is 7 meters above the ground. Was launched from here, goes to a maximum height, comes down. So it's like it's a downward opening parabola, which models the motion of a projectile or anything thrown above. Okay, so from 7 meters goes up to 51.1 meters, and then comes down. So on the y-axis we're representing height, and on the x-axis time. So according to this, when it's launched at this point, let's say t is equal to t naught, after 3 seconds, it has reached the maximum height after 3 seconds. So if you look at this graph carefully, it's a symmetrical graph. 51.1 meters is the y coordinate of the vertex of the graph. And t naught plus 3 seconds, that's the x coordinate of the vertex. So the rest of the motion will again take 3 seconds due to symmetricity. And after 3 seconds, it will come down to 7 meters. So what's the total time from the launch? They're asking how many seconds after the launch does the model estimate it will return to the height of 7 meters. So not 3 seconds, because that was after reaching the maximum point. It's from the launch. So it's 3 plus 3, 6 seconds. So the question was pretty long, but it's a really, really simple question. Okay. It has been categorized into the hard category, but then it's not that hard. So just need to be careful. Don't skip such questions. Always gives the questions a thorough read so that you don't miss out on the easy questions disguised as difficult ones. Okay, let's go to the next one. There's a function given to us, f of x is equal to absolute value of 59 minus 2x. The function f is defined by the given equation. For which of the following values of k does f of k is equal to 3k? Okay, so the function is given to us, modulus function or absolute value function, 59 minus 2x. It's saying for what value of k does f of k equal to 3k? Let's replace x by k and check. So f of k will become 59 minus 2k. This is equal to 3k. Once we open the modulus, what's the rules for the absolute value function to open? It will be like 59 minus 2k is equal to plus minus 3k. So one equation becomes 59 minus 2k is equal to 3k. The other becomes 59 minus 2k is equal to negative 3k. So from the second equation, we get negative 3k plus 2k. So negative k is equal to 59, or k is equal to negative 59. This is one of the answers, one of the values of k. And the other value is 59 is equal to 5k. K is equal to 59 over 5. Option A, that's the correct one. Simple question, following the rules. So as the topic is named, nonlinear functions, so you'll get all kinds of nonlinear functions, including quadratic, absolute value function, exponential function. These three are mainly included in the syllabus. Let's go to the next one. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? Okay, so exponential function f, the value of f of 1 is k. Exponential function will be of the form, let's say some constant a b raised power x. Let's say this is a standard exponential function. For f of 1, when x is equal to 1, the value will become ab, which is k. K is the constant. Okay. In reality, a and b might have different values. Like when we get to know, the product of a and b is k, which is the constant. So now they're asking to look at the options and find out which of the following equivalent forms of the function f show the value of k in the coefficient or the base. So either this or this, the value of k. Okay. So if I put x is equal to 1 in all of these four, let's check. So for option A, x is equal to 1 becomes 2 squared, so which is 4. 4 times 50 is a 200. 200 is not present in either the coefficient or the base. So option A is wrong. Second, x is equal to 1. 80 times 2, that's 160, which is not present in 80 or 2. Wrong again. 128 times 2 raised by x minus 1. Now if I do x is equal to 1 here, this will become a 0. 2 raised by 0 is a 1. That means the answer is 128, and 128 is present as the coefficient here. Okay, so option C is correct. Option D, let's check. If I put x is equal to 1, 1 minus 2, this becomes a negative 1, which means 205 divided by 2, which is not present in the coefficient or the base. So we do not need to check option D, but I just checked for better understanding. Option C is the correct one. Okay, and the question's language might look a little difficult to understand, like the last line, which of the following equivalent forms of the function f shows the value of k as the coefficient or the base. So value of k was nothing but an indicator of putting x as 1, which is mentioned here. Putting the variable's value as 1 and checking if the answer is equal to either the coefficient or the base. So either this or the coefficient. This 128, 2 raised by x minus 1, this is the base, this is the coefficient. Okay, let's go on to the next question. A rubber ball bounces upward 1/2 the height that it falls each time it hits the ground. If the ball was originally dropped from a distance of 20 feet above the ground, what was its maximum height above the ground in feet between the third and the fourth time it hit the ground. Okay, so these kind of questions are seen very often on the paper. A lot of my students have been a bit confused on these kind of questions, how to deal with them. Looks difficult, but it's not. Okay, so I'm taking this question as an opportunity to explain you the scenario that we need to analyze. Okay, so the rubber ball is getting dropped from a certain height. Let's say this is the ground. It's getting dropped from a height h. Okay, gets dropped, comes down, bounces, goes up like this, then comes down again, goes up. This is how the motion is finally restricted. Okay, so initially it was h, they're saying it's 20 feet, and it always bounces one half of the height that it has fallen through. So it fell through h in the first drop. First drop happens here. This is the first bounce. Okay, next this one, this is going to be h by 2 because one half the height from the first. This is the second bounce. After second bounce it goes h by 4. Third bounce h by 8. This is the fourth bounce. Then h by 16, and this is the fifth bounce. This is how it goes. They're asking you what was its maximum height above the ground in feet between the third and fourth time it hit the ground. Third, this. Fourth, this. What's the maximum height? h by 8. H is 20, 20 over 8, which is 2.5 feet. So it's as simple as this, the question. They can make it more complicated by modeling it with a quadratic equation or asking you to do it, but you'll be given the required information. You basically need either the starting time instant, or you need the vertex, like either x coordinate or y coordinate of the vertex, like the maximum height reached, or the total time of travel. You can use these kind of things to model the complete equation. If we get any such questions, I'll be more than happy to explain the complete scenario. If you have any questions of this kind, share them in the comments and I'll take them up in the next video. So stay tuned. We're ending this video here. The part 3 of the hard questions for nonlinear functions will be up in a few days. Keep practicing. Take care. Bye-bye.